Good morning, my super friends. Last time I started a live stream, I had no audio to begin with, so hopefully it's all working now. In fact, just before I started, 1 minute ago, I suddenly realized I didn't have a microphone plugged in. So, first up, my shout out for today goes to this page on the Australians Together site, which just talks about the importance of Aboriginal culture and our understanding of it. So, interesting stuff. Cool. Audio is good. Thanks, John. Thanks, Sion. Good morning. It's good to see you all here. I can see Frank. There's Daniel. Dodgy's here. And Sparky's here. And Austin's Creations. Raspberry. Very good. Okay, so now last week we did the unboxing of this. So James's amazing creation. And right now on the camera you can see that it's looking very blown out in terms of, what I mean by that is it's overexposed, it's very, very bright, and you can't really make out what it is. Aha, oh, Henrik said it's not morning, it's nighttime in Estonia. Yeah, I'd like to be in Estonia. That would be cool. In fact, it'd be more than cool. It'd be cold right now. It must be freezing over there at the moment. So yeah, hanging out in Tallinn would be really nice right now. Maybe sort of in that town square area where there are the, where the Christmas tree gets set up and where there's a little cafe sort of half underground, just around the edge of the cafe. Just around the edge of that square. It's very cool. Tallinn is a great place. So the display, as the LEDs move, you can just see part of the name being revealed there. And if I turn the brightness on this way, way down, you'll see something start to happen. So because of the way the camera picks it up, when I have the brightness turned up to, I don't know, say here, if I just look at that, I can see that perfectly clearly just because of the way the eye responds to the light. But if I turn it right down so that the camera can see it better, so that's with the brightness turned way, way down, that's about right. You can see it there. It's got the super house, it says super and then the logo and then house. But you can see that there's a whole lot of flickering around the word house. I'm not sure what that is. It only happened, it's quite strange. It's right at the end of the chain of LEDs, and the lower the brightness, the more LEDs flicker at the end. So I've got it turned down very low at the moment. You can see that most of the word house is flickering like crazy. It's flashing really brightly. If I turn the brightness up a little bit, and you'll see that, well, you can't really tell, but turn it up a little bit more, and what you'll see is that less of the word house flashes like crazy. It's more towards the end. I'll bring the brightness further up. Now it's just the end of the word that is flashing like crazy. And taking the brightness up. Now it's just right at the end on the E. And the brightness up a bit higher. And if I get it up high enough, I think that's about it. It doesn't flash at all. So the pattern is consistent all the way through it. So there's something strange going on in the LED strip. So Zero suggested voltage drop at the end of the LED strip. The thing is that it's behaving the opposite of what I would expect with a voltage drop, because when you would get a voltage drop if the DC-DC converters are running close to the limit and they're having trouble supplying the current. But what's happening is that when I turn the brightness down, that's when it starts misbehaving. If it was voltage drop, I would think that when you turn the brightness up, it would start misbehaving. So it's actually the opposite of what I would expect. So anyway, there is an issue to debug there. So what I'm going to do is turn it down to a very low brightness again. So you can see it says super house, except that the house flashes a bit like crazy. Station 240 said could also be degradation of signal or noise on the voltage rails. Yeah, so I haven't actually investigated this. I'm just observing that this is what's happening. So I haven't actually stuck multimeters on it or try to check what's going on. And yeah, but I will. All I'm doing at the moment is observing the behavior and reporting it. Now, last week we played around with the light switch. I've got this one right here. This is the one that we were playing with. So it's the latest prototype, which is probably actually going to be the production version of my new version of the light switch. So it has got the RJ45 socket on it, so it acts just like a simple switch where the buttons are on the end of a long bit of wire and you can use it with a light switch controller. And it doesn't have any dependency on the electronics on it to operate properly. But it does also have an ESP8266 in it, and it's got RGB LEDs in here, so that we can do things like show the state of a load by changing the color on the LEDs. And Henrik said the addressable LEDs start to flicker if the data is weak. That's interesting. So maybe, actually there are more than 3 DC-DC modules. So Station 240 said it's got multiple voltage regulators, though I see the inside photos on Discord shows 3 DC-DC modules. I think there are actually about 5 or 6. And I plugged it into my bench power supply, and when I'm running it fairly brightly, it's pulling a bit over an amp at 12 volts. And since the LEDs are split up between various DC-DC converters, I think it's well within the capability of the converters. They shouldn't be running anywhere near their limit. Anyway, so light switches. Has Big Clive finished yet? Last time I looked, he had some kind of shiny hammer that he was showing off, but that was earlier while I was eating breakfast. So, all right, where we left it last week was I was messing around in Node-RED, and we had some things working in the light switch. We could do things like we could publish to MQTT and then have the color of the switch change by changing the LEDs on the RGB LEDs on the light switch. So, I've just had one of those really weird moments where it seems strange to me right now to be sitting here in this room totally alone. It feels like I'm talking to myself. It's very weird. Even though all of you are out there, I know. It's just sometimes I had one of those moments where I step outside of myself and I look at what I'm doing, and I'm sitting here alone in the room talking to a camera. All right. So what I've got here today to play with are the light switch, and also down on the bench, which you can't see just yet, there is an Ether Mega, which is going to be a stand-in for the light switch controller. So I don't have the complete light switch controller, but I've got an Ether Mega, and then we can run some code on it. And yesterday I spent a fair while messing around with editing my old light switch controller code and making it work with basically publishing differently. And we'll look at the source code of that. So where are we going to sorry, distracted by the chat. All right. Where are we going to start with this? All right, let's have a look. See if this camera is working. I haven't actually pre-tested this camera. So go to overhead camera. Let's drag this out a bit. It's on a little slide rail up the top here. So I can adjust the position of the camera and it looks straight down on the bench. So I've got an Ether Mega here, and this is currently running the code which I've been modifying for the light switch controller. So this is what would be inside the controller, and then various inputs are used to connect to the light switches. And because I was being kind of lazy, all I did was get a jumper wire, plug it into ground, and then I can just stick it into the headers and that simulates pressing the buttons. So that's how I was testing the changes to the code. And I also have here the light switch that we were playing with last week. And right now, that is not connected to anything through the RJ45 connection. It's just got a power connection coming in here. In fact, it's plugged into a battery. So I was playing with this in the lounge room last night and I didn't have a power supply in there. So I just plugged into this battery out of my drone, and let's see if it does anything. Yes, it does. Okay, so if I press the button, it goes blue. Press it again, it goes red. Blue, red. And we'll have a look at what's going on in Node Red and in the controller code and start to put all these different pieces together. Now, let's have a look at some things in Node Red just as a refresher on where we were up to. Now, what we had, I'll get this so that you can see, let's see, how far do I drag it out? Drag it out to about there, that'll do. That gives us enough room. Alright, so there are a few miscellaneous things on here that I was playing around with, because when I was looking at, last week we were looking at taking data from the light switch. So we've got Tasmota, so this light switch right now is running Tasmota, and it's got set option 73 active, which disconnects the button presses from the state of the output. So when you press the button, it doesn't actually toggle any output. All it does is report to MQTT the fact that a button press has happened. And let's see if, do I have one? No, okay. I'll get back to that. We'll get back to that particular part of it. But where we were at was being able to send different color events. So this MQTT publication, so that is the topic for, oh, you can't really see it there very well, but you can see on the overhead view, the button that's currently red, that's button 3, because it goes 1, 2, 3, 4. They're counted vertically. I don't know why, that's just the, I think because I started off with a single button and then 2 buttons and it was above each other. So 1, 2, and then I did a triple button, so it was 1, 2, 3. And so I got used to the idea of the buttons being numbered vertically. So when I did the 4-way button, it was 1, 2, 3, 4. So it's 2 vertical rows. It would probably make more sense if it was across 1, 2, 3, 4. Anyway, that's just the way it is. So LED 3 is the, oh, you can see it better here. LED 3 in this MQTT topic is that LED in the top right corner of the button. So if we publish to that LED, we can change the color of the button. And in here we've got a switch node, and it either sends to output 1 or output 2 depending on the payload, whether it's 1 or 0. So 1 is to turn it on, 0 is to turn it off. And if it goes out output 1, which is the on, it sets the color to 440000. Let's change that. Let's make it go to green. So it's RGB, red, green, blue. We'll make it go to green if it's turned on, and the off color at the moment is going to red, green, blue. It's going to blue. So I'll just deploy this. And I know without context this is probably not making a huge amount of sense, but it'll all start to come together in just a moment. Now I'll press this a couple of times so it toggles its state. So it goes to blue, press it again, and now you can see that it's green. So now it'll be toggling between green and blue because I changed that value in Node Red. But what is going on here? Okay, let's look at the chain from the start. We've got the button, which is how I'm asserting what I want to happen. When I press that button, Tasmota, which is running on this ESP8266, sees that there is a button press on button 3, and it publishes to MQTT. So let's check that out. back to the desktop, and this is where it's coming in. So what we've got here is a subscription to the result topic for that particular device, which is Tasmota 8DC685. Now, as a matter of interest, let's grab a debug node, and I'm going to show you a couple of things. We'll turn that one off. In fact, let's stick another debug node in there and pull this out to here. And I know I could have done those both on the same debug node, but at least this way I can individually turn them on and off. So we deployed it. What do we want? Debug, and we want only on current flow, clear. Okay, so they're both turned on. So what we've got is the result of the subscription from that topic. This subscription here is what Tasmota is going to be publishing to. So if I press, I'll press button 4 and we'll see what happens. Okay, so we've got these debug nodes have given us the output directly from the subscription and from this JSON converter. So what we've got here is, oh yeah, there's an error there as well. We can ignore that for now. So what we've got here is the publication. It was on that topic, and the payload was button 4 action single. And then if we look at this one, it's the same thing, but it's been through that little JSON decoder. So we can now spin down the tree structure and we can see it's published and it was button 4 and the action is single. In fact, so I'm going to clear this and I'll turn this one off so we only get, oh yeah, and I'm jumping around all over the place here. This is probably not making a huge amount of sense. Ooh, I'm going to come back to the comments in a moment because it looks like there are a couple of questions. So, all right, from the start again. We've got a subscription to this MQTT topic. Tasmota publishes to that whenever a button is pressed. The output of that subscription comes into this node, which converts between the JSON string and an object. So we're getting a chunk of JSON coming in from Tasmota, and we convert it into a node red object. And then what we're doing is echoing, well, you know, outputting, whatever, the result of that. So that's what's coming out on this debug node and appearing in here so that we can watch what's going on and see what data is being published. So if I just press button 3 once, we get this, and it says, sorry, I pressed button 4, and it says action single. Now, because Tasmota supports different types of button events, I'm going to press and hold button 4. So I'm just pressing it, and I'll keep holding it. I don't actually know how long. Oh, there it is. Okay, it must be like 5 seconds. So now we've got another event that's been published. And if we come down to payload, button 4, and you can see action hold. So if you just press it once, you get an action of single. If you press it and hold it, then you get an action of hold. I think there's a long press as well, but I don't know how long it is. Let's just try like 2 seconds. 1, 2, let go. Let's see, what happened here? Payload, object, single. No, it's still single. Yeah, so anyway, I haven't really looked into it in detail, but there are different types of presses. I wonder if it can do like a double press, like a quick double tap. I'm just going to try. Ooh, I think it did. I'm going to, unless it just saw that as a single press. Let's see. Oh, it was a double. Awesome. Okay, so it can detect double press events. So we've got single press, we've got double press, and we've got hold. And each of those gets reported differently by Tasmota when we press those buttons. Mako, you're always fashionable. Yeah, okay, so ignoring everything else on this flow. So ignore all of that stuff at the top, ignore this stuff down here that we'll get to in a minute, ignore this toggle thing. What we've got so far is just an MQTT subscription, converting it from JSON, I wonder if I can zoom this in just to make it easier to read on screen, because I know it's... Does it work? Yes! I can zoom. Cool. Okay. Maybe this will make things a bit easier. Okay. So really, these two nodes, the MQTT subscription and converting from JSON, then gives you all sorts of useful stuff, because what's coming out of this JSON converter is these messages like button for action double. So then we can do logic based on what those things, on what those actions are, and also things like which button was pressed, so we can distinguish between them. So this is the stuff that I began playing around with right at the end of the live stream last week, and at the time my brain was really not in it and I kind of gave up because 2 hours was up, and it would have been just painful watching me struggling around trying to figure it out. Ooh, Frederick said Tasmota supports up to 5 presses at once. Unsure if it's enabled by default. And by at once means, quick presses, like 5 quick presses or 3 quick presses. Yeah. Okay, so alright, I'll get back to that in just a second, but I just saw in the chat. So going back to the to James's really cool little animated display here. So Zero said, so just hook up an oscilloscope at various points in the data line. Yes, that's what I'm planning to do. I really want to debug this because this display is so cool. I want to be able to have that running and then link it to MQTT so that it can be triggered and do different things off the chat. I said I was going to do that for this week, but I haven't. I have actually played around with MQTT, and I've sent commands to it by MQTT, but I haven't linked it to the chat, and that's because I kind of got distracted by that fault and thinking I really need to fix that first. Alright, so... and Austin's Creation said, I'd add a 74AHCT125 level shifter after super, and then again for the input of house. Thus the signal would be boosted for the logo and the word house. Yeah, I don't know if it's necessary. It's certainly a good idea, putting a level shifter in there, because that way you get a nice strong signal. Now the thing is that I don't actually even know what the LEDs are that's in this. Maybe they're WS2812s? I don't know. I haven't seen the front of the PCB, so other than the photos. But the thing is that with pretty much all addressable LEDs, and when I say addressable, I know people who are pedantic are going to say they're not really addressable, they don't have an address, it's just a position in a sequence. They have built-in level shifters. Well, not really a level shifter. They have the output is being driven actively by each LED in the chain, which means that if you can get a good signal into the first LED, then it will produce a signal at the correct voltage level for the next LED in the chain, and it cleans up the timing and everything else. So you don't get things like capacitance down the line causing signal degradation. In theory, the signal that is between the last 2 LEDs should be just as tight and well defined as the signal going into the first LED, unless there's something going wrong with the chain. James said WS2812B. Yes, cool. And so that is, yeah, so in theory it shouldn't be that. And the other thing that is a little bit strange about this fault is the position of it changes depending on the brightness level. So as I turn the brightness down, the fault extends further along the chain from the end. When the brightness is, as you turn the brightness up, the fault moves closer and closer to the end and then disappears entirely. It's all very mysterious. Oh, Scott Miller said, it's a shift register. Yes, exactly. That is basically what it is. It's a big shift register. It's a it's a cluster of shift registers, a cluster of 1-bit shift registers. Yeah, all right, okay. Back to, where were we? All right. I've been chasing the flashing squirrel. Oh, Rando Hin said, debating whether to go to sleep or power up my laptop and do stuff. It's 1:25 a.m. For me, that would be a bit late to be starting something new. It's not unusual to be working on something at that time, but I would definitely be trying to wrap it up. Not starting a new thing, unless you want to see the sunrise. Okay, so back to this. Alright, so we've got events coming through. We're decoding them and turning them into Node-RED objects and outputting them here in the debug console. So what we can do now is change things based on that message, like whether it was a single or a double and which button was pressed, all of that sort of thing. And that is where this node comes in, toggle test switch. Now, I'm actually going to back up a little. I'm going to show you this sequence slightly backwards so that it makes sense. In fact, I'm going to get rid of that link and break it, because this little sequence here, in fact, I'm going to get rid of, or am I? Hang on. Do I need it in there? Test switch? No, I don't. Okay. In fact, I'm going to get rid of that link and move this out of the way a little bit so that you can see, and I'll move this along. All right. Now what you have at the top here is a minimal group of nodes which will turn the LED output on or off, or between those two different colors. It doesn't actually do anything else useful. All it does is turn the LED on the switch on and off, or switch colors. And so what we've got here is a Node-RED dashboard node, and this is just called test switch. And if I open my phone and went to the Node-RED dashboard, this would be a little toggle switch that you can just click and it turns on and off. So it's got two states. It's either on or it's off. And the output comes through to this switch. And if it's 1, which is on, then it sets the payload to that color. If it's off, so 0 off, it sets the payload to this color. And this could have all been done in a single function, in a single node as well. I know, I could have just made that like an if or something. And in fact, what I could have done is set the payload in here. No. Well, all right, that could be a single node, but that doesn't matter. So what I could have done is inside here just done a an if message.payload is 1, then set message.payload to that. And if it's 0, set it to the other. So that could be one node. And then the output of that is just published to MQTT to change the state of this LED. Now, if I was actually wanting the switch to do something, you know, like be useful, what I would do is have another publication here. In fact, you can see an example. If I go to living area, I should do it. Okay, here's an example. So this is the switch for lounge lights. It comes into this switch. This is basically the same thing. It's making a decision to go to output 1 or output 2 depending on the payload. So on or off. And then this is what we're just looking at. So we're setting an on color and an off color. But up here we can also have an on message. And in this case the payload is on equals 7,11, and the off is the payload is off 7,11, which won't make any sense to you, and that doesn't matter. That's not the point. What it's doing is that when the switch is turning on, it sends one message. When it's turning off, it sends a different message. And in both cases, that message is to an HTTP request, which goes to my switchboard, and it turns lights on and off. That part of it's not important. But the significance is that these nodes here are what is actually turning on and off the lights. And these nodes here are what are changing the color on the light switch to make it show an on state or an off state. And by combining all of these, we can turn lights on and off, and we can reflect that state on the light switch. All right, so back to flow 1. So what we're looking at here is essentially a simplified version of that. All it's doing is reflecting the state of that switch on the LED. But with a very simple addition, like you could drag out from here and send it to whatever you wanted. It could be another MQTT publication, like it could be sending a message to a Sonoff or to, whatever device it is that you're using. Whatever it is you want to control can hang off here. That part of it's pretty straightforward. So, all right, what we have here is a switch object which can turn on or turn off, and it changes the color on the LEDs. All right, so what were the rest of these things? Now, this node here, set state test switch, what this is doing is setting a variable which is within the scope of this particular flow. And so you can see set flow.state test switch, and it could be global as well, but this one's just set to within this flow, and it's setting it to message payload. So what this is doing, and then we link this down to here, so whenever this switch turns on or off, whatever that is, it gets stored into this variable. And you'll see that there's no output from this node. This doesn't actually go anywhere. All it's doing is taking whatever last event happened at that switch and storing it away for future reference. And then other nodes can use it. Now, what we do is going back to the button press here, what we want to do is we've got so we've got test switch, which is the Node-RED dashboard object, and normally you wouldn't have any input to this. The switch itself on the dashboard is the input. That's how you control it. But you can also send input into it to override it, and that's what this link is about. And the thing I haven't shown you yet, which makes all of this work, is this thing here, toggle test switch. Now if we open that up, we'll see that there is a bit of JavaScript in here. So what this is doing is looking at the button event that's just happened. So if we press button 3 and the action is single, then it is getting the state of that variable. So what it's doing is looking up what is the current state of the switch, and then it's just inverting it basically. And yes, I know this is probably not very elegant code, but well, it's working at the moment. So if the state is true, then it sets the payload to false, and if it's not true, then it sets it to true, and then it just returns that message. So, but that's basically just a toggle. If you, the trick here, and it looks like there's no link to it. See this node hanging out here? It's just hanging out on its own, doing nothing much. This state test switch variable, which is being set, is being referenced back in here. So this is what, it's kind of it's a non-linear flow, I suppose, in some ways. So starting from here, the button press comes in, it gets converted, and this then looks up down the chain to find the current state of the switch. It inverts it, whatever the opposite is, it sends it into test switch, which comes through here. Test switch changes its state, and it stores the new state into here, and the output comes along, goes to on color and off color, and yada yada yada. It all works. So, I'm just going to hit deploy because I've been dragging stuff around. I'm not sure what state it was deployed in. But the end result of all of that, what we're looking at right here is, Hopefully I haven't broken anything. That logic is what is currently making this change color. So you press the button, oh, it turned off entirely. That was interesting. So that is weird. I wonder if it was detecting that as a different type of button press. I'm just going to do it a little bit more slowly in case it was seeing it as a double press. It probably was actually. So I'm pressing it more slowly now. And it's switching between the two states. And if we had, as I said earlier, if we had something else hanging out of this switch, we could actually be turning things on and off. In fact, I could make this do things like turn on and off the lab lights. So let's do that, just for the fun of it. Where is it? Bench lights, office lights. Let's grab, come on, got to select over there, grab these two and come back into here, paste them in. And yes, I know, I've sort of seen out of the corner of my eye that there are a bunch of comments and I probably need to come in and check out what they are. Alright, so now what we've got is when it turns on, it'll form this message, which is on 13, 14, 15, and it will make an HTTP request to my switchboard. When it's off, it does that. So let's deploy this. And now, this light switch should control my office lights. Let's just see if it does. Hey, it's just turned on the lights. And it's gone green, which is the on state. Press it again, turns off the lights, and it goes blue. So, just to check, set state, is it going to work? Oh, it should, okay. Sorry, I was just pondering then whether I had messed things up by doing this in a different flow, but I haven't. Alright, so let's just go to, where is test switch? In fact, I don't even know where test switch is inside my dashboard. It's in home living areas. Okay, so living area, test switch. Here we go, I'll get this down here so you can see it. Alright, so this is the Node-RED dashboard on my phone. This is the light that is controlling the office lights, and you can see test switch here is currently on. So I will turn test switch off, and the LED went blue to indicate the status, and the office lights turned off. And then press it again, lights come on, and it goes green. And the opposite way, so if you're watching test switch there, it's currently on. If I press this, the lights turn off, and the status updates here. And the LED here changed color. So now we've got all of the elements interacting. We've got detection of the button presses on the light switch. The light switch is changing its color to reflect the state of the load. Button presses are toggling an output. In this case, it's my office lights. And all of that is also being reflected on the Node-RED dashboard. So that is actually complete functionality and this is with no light switch controller. It's doing this 100% through Tasmota and MQTT. So this is not plugged into anything other than power. Now, so in theory what I could do is if I replaced all my light switches in my house with these, I would not need a light switch controller anymore, and I would not need the Cat5 cabling going to each light switch location. Now, I am going to keep using a light switch controller, and the reason for that is that it gives, it means that I have fewer points of failure. I could go off on a sidetrack now talking about this, but I'll try not to chase that squirrel. I've talked about this in the past. The problem I found with having too much logic within individual light switches is that it means that the probability that there will be a light switch having problems is higher. Because if you have, say you have a light switch, say we have a light switch here, and something goes wrong with it, and it crashes, say, once every 2 years. And, you know, that might sound fine. Okay, once in 2 years, you're going to have a problem with your light switch. But if you've got 24 light switches in your house, it means that you're going to have one failing every month. And after a while, that drives you crazy. If you've got 48 light switches, you'll have a light switch failing every 2 weeks. And by failing, I don't necessarily even mean permanent failure. I just mean some kind of a glitch. Like it falls off Wi-Fi and it can't reconnect. Or, you know, whatever. There could be some relatively minor thing, and it might just need to be power cycled. And that might happen every 2 years for each individual switch. But if on average it's happening every 2 weeks or every 4 weeks, it's going to drive you insane. So that's really the reasoning behind my philosophy about making the light switches as simple as possible. Just switches on the end of a long bit of wire connected to a light switch controller. And with these, use the onboard smarts for non-critical functions, like changing the color of the switches to reflect the state of the load or whatever it is that you're changing. And if that non-critical functionality fails, no one's going to be yelling at you. Well, hopefully not. Okay. Now, I'm going to have a quick look back at chat. What have I been missing? All right, so, there have been discussions about the weather. So, I suppose that's a safe topic. So, we will not discuss, there are other topics we will not discuss, but weather is safe. Yeah, I don't like it to be too hot either. So, Dodgy said, define hot, maker. What state you are from depends on what you call hot. Had some coolish weather up north around 25 to 30 degrees. Yeah, that would be coolish up north. And Mako said, 25 to 30 is bearable for me. It snowed here today. Oh, snow would be cool. White Christmas would be cool. Yeah. I like it when it's not too hot. Okay, so some direct feedback on this node red stuff. Scott Miller said, in a function node, message.color equals message.payload, question mark, green or dark red will give you outputs based on true, false. Awesome. So there's a nice little bit of optimization, and that's, what's that called? A ternary operator, something like that. Let's give that a try. I'm going to, what I'll do is I'm just going to copy these nodes and paste them. Oh, you can't see what I'm doing. Not properly anyway. Paste them down there just to get rid of them. I'm going to delete that. I'll bring this down here, and I will just call this node something like set color. And we want something like, oh, so you can use green and dark red. Are they, so Tasmota will, oops, what am I doing? Function, yeah. So Tasmota will take those named colors. So message.payload, green or dark red, does that work? I'm not sure if I've got the syntax correct. Let's just try deploy, and we will see what happens. It hasn't complained. That's a start. All right, so let's switch back to overhead. And, oh, no, before I do, I'm going to disconnect this from my office lights, just so that it doesn't keep turning them on and off as I play around with it, which will make the camera keep trying to adjust its levels and doing stuff. All right, so I press it, turns off, still off, still off. Okay, there is something not working there. So what have I messed up in this syntax? Message.color, return, hang on, message.color, that's right. I was doing it on message.payload, I believe. Yeah, message.payload is that. So let's do message, come on, message.payload is that. So it's going to come in, message.payload will come in as 1 or 0, or true or false, and it will be changed so that it is the value of the color which then gets published to MQTT. Because in this node, which is publishing to MQTT, whatever is the payload that comes into this node is the message that is published. So let's just try that. So press it once, press it twice. Still, oh, hang on, green. Okay, that's better. Press it again. No. All right, so we got a green. All right, so there is still something going on here in this logic. So message.payload and message.payload equals that. Question either green or red based on true or false. I think it might be because it's not getting a true or a false, it's getting a 1 or a 0. So if it's 1, it goes to output 1, and 1, or if it's a 1, what? Output, oh! What am I doing? I don't even need this switch node anymore. All right, let's move this up here. Of course. Sorry, Scott. Because what I can do is take the output of test switch and just feed it straight into that. So this will simplify things a bit. Let's see if this does it. Aha, red, green, red, green. Scott, you're a champion. Thank you for that tip. So we can get rid of the switch node, we can get rid of, well, these are, yeah, this is cool. This is like getting the smart kid to help me with my homework. So what I can do is bring this back over here, make some more room. It'd be nice if I could fit all of this on the screen a bit better. Let's go back to there. So we've got test switch, and its output is going to be true or false, and then it comes into this node, and then based on whether it's true or false, it's going to give it either green or dark red as the two colors. And what we could be doing is putting like RGB values in there instead, but we're just using named colors which Tasmota can understand. And then we are publishing those named colors to this topic and changing the changing the color of the LED. All right, so if we did, that simplifies changing the color of the LEDs. That's really cool. So it gets us down to the switch node, the set color, and the publication. Doesn't get much simpler than that. And then this node hanging off here for the variable that holds the switch state is still required at the moment because we need it in this one to decide which message to send. So if there was an input into here, so what have we got? Okay, so on payload true or false, if we could send a payload that was something like toggle into the dashboard node and it would just invert its state, that would be nice. Maybe there's a way to do that. All right, that's a squirrel I'm not going to chase right now. Now, just before I keep going with this, I'm just going to check if there are other comments. So James said, so this is talking about the display. I wonder if the issue could be a bad LED somewhere on the chain. I had an issue with one of the super boards, but replacing it fixed the issue. Then again, I bench tested these. Yeah, I don't know. The thing that makes me wonder, the thing that really throws me on this is that the position of the error moves. So if there was a specific spot where things went wrong after that point, that would really make me think, oh, there's an LED that needs to be replaced. But it's not. It seems to be based on brightness. And you can see there, back to this view so you can see it. So this is with the brightness set really low. Oh, and in fact, I'll pull this in so that you can see it. Desktop. All right. So this is the WLED interface. And you can see there's a brightness slider up in the top right here. And if I take the, so the brightness is very low at the moment. If I take the brightness up to about a third, look at that, the flickering has gone away, and it's overexposing at the moment, so the camera can't, it just sees it as blobs of light, but the flickering has gone. Now if I bring it down a bit, you can see the flickering is just touching the end. It's the very last LEDs, and bring it down a little bit more, and now there will be flickering across more of the LEDs, and a little bit more, and then the flickering is slowly working its way back along the word house, starting with E and then, you know, moving along. Make it a little bit dimmer. Now more of the word flickers, and bringing the brightness right down, and now the flickering progresses further along. Actually, what happens if I bring it right down to, how far can I make it go? Don't know. So I've got the brightness almost at 0 now. You can see the flickering, it doesn't really go, it goes partly into the H, but it doesn't come further back than that. It never actually makes it to the logo. So, yeah, what's really throwing me is the fact that it moves. I don't understand why this is occurring depending on the brightness. So, all right. I will figure that out later. Now, oh, Henrik said, what was the code to turn on the Node Red app? Sorry, Henrik, I don't really understand that question. What was the code to turn on the Node Red app? What was the Node Red app? That is the dashboard. Okay, so if you come into Manage Palette on here, and the ones that I've got installed, where is it? Node Red dashboard. If you install this set of nodes to the palette, oh look, I'm out of date. So the Node Red dashboard, that is what gives you the various things that are on my phone. So to actually load it, what you do is you go to the URL, which is, in fact I can show you here. I'm going to grab this and go to the same address as your normal Node Red. So you know your host name and then the port 1880, and then you just add UI on the end, and now it will come up and you can see here all of the dashboard nodes. So that one we've been playing around with, where are we? Somewhere in living area. There it is, test switch. So this test switch here is the one that we've been messing around with. And it just appears there because it exists in here, test switch, that one right there. So by adding extra nodes into here, extra dashboard nodes, they then appear in this view here. And then you can load that up on your phone. Yeah. Alright, so Dodgy said, so this is a really good question actually. So where does the state get stored if it isn't connected to a database? Or does Node Red just store the state? Yeah, Scott already answered. Just inside the flow in Node Red, yes. But for anyone else that was wondering, that is a very good question. So this little thing here, this function, what it's doing is set, where are we? The rule is set. This is actually a change node, but you know, what I've normally I'm not going to change this now, but what you can do is select set, and then it's going to set a variable. The variable is, in this case, is called state underscore test switch. Whoops, I didn't want to do that. I hit the keyboard. So the variable is called state test switch, and you can define the scope of that variable, and that is set by this little drop down just here. So the variable can be just within this message, it can be within this flow, or it can be global. Now if I set this flow to the state to the scope to global, and I will actually save that now. What that means is that I could go into a totally different flow. Like I could come over here somewhere and I could reference that variable inside. So let's see. Let's pick one. Where is one that matters? Oh, it doesn't. Anyway, I could reference that variable inside a function on a totally different flow, and it's a way of passing data around between different nodes and between different flows. So it's just stored within. Sorry, I was going to say it's not non-volatile. It's volatile. So it's a variable that is simply stored within the context of the running node-RED process. And if you restart node-RED, it all goes away. It starts from nothing. And that is actually why on this toggle test switch node, so this is how you reference it. It's got flow.get state test switch. And that's referencing the current value of that variable. Now you'll see that it is, if var my state is that or false, and in this case, false is, the reason I've included the or false is because if you restart node-RED, the value of that is undefined because the value of variable hasn't been set yet. Like it's not true, it's not false, it's nothing. So you need this little thing here, even though it's saying or false, catches that circumstance. So it means that you don't get an error. Yeah, I might be wrong about that. It's a long time since I've looked at that, but I vaguely recall that by adding that or false at the end, it meant that if the variable was undefined, like a null value, then you wouldn't get an error. It would treat it as false or something. Anyway. Where are we? Okay. So answering that question, yeah, what this is doing is just setting a variable and storing it in memory within node-RED so that you can reference it. All right, now where are we? Zero said, node-RED can be configured to persist variables if you want to. Yeah, otherwise it's in memory and go on with a restart. Yes, exactly. So I don't have any persistence set in this. I've not bothered with that. I think you can use, it's got some options for persistence. I think it can use MongoDB or a couple of other options. But yes. Where are we? Sorry, scrolling back up in the chat here to see what else I might have missed. Harold said, oh, thank you, Harold. You have an excellent channel and I've learned lots from you for my superhouse. Well, thank you. Thank you for coming along. I have missed a lot of chat. I've got to go way, way back. All right, so we'll get back to the node-RED stuff in a moment, but I'll try to catch up with chat for now. I'm so far back that these are probably referencing things I've already changed. Frederick Angel Mo said, could you have gone directly from toggle test switch node to the color node if you combine the color nodes? Toggle test switch node to the color node and go from toggle test switch to set color if we combine the color nodes. I don't think so. I think maybe I'm misunderstanding this question. I think that question is, can you go straight from toggle test switch, so the output of this, and combine it with the set color or feed it into here. Now the reason that they are not combined is that this part of the flow needs to operate from this dashboard node. So there are really two different ways that whatever the load is being switched can change. One is if you press the button, the physical button, and the other is if you use the dashboard node in Node Red, like on your phone or in a browser like this. So by taking the output from this and merging it into here, it's bypassing this, and that means that the two switches can get out of sync, and then you might have to press it twice to make it work, and it won't reflect the state in here. So there might be a way to optimize that. Maybe I'm misinterpreting that question, but that's the reason that I did it this way. Was that switch? Oh, switch bounce? No, Tasmota. Yeah. So when I was messing around earlier, and it was going, when I was pressing the button and it was going to a dark state, not between the red and the green. I think that's because I was sitting there pressing it like this to make it toggle, and it was Tasmota was interpreting it as a multi-press. Multi-pass. Okay, so demounts node needed. Quick, someone send. Oh, my phone is off. Does anybody in the chat here have my phone number? There'd be a few people that do actually, but no, my phone. I've got Do Not Disturb set on my phone at the moment. I will. I'll make it live. But yeah, if my phone was on the bench and you sent me a message, you'd probably see it. Oh. Yeah, okay. So, oh, this is an interesting point. So Jordan Reese said you could always use them as a backup when or if your light switch controller is offline. Yeah, this is really interesting. So with these light switches, we've got two ways of taking data from them. One is through the light switch controller, and the other is by the device publishing to MQTT. And I hadn't actually thought of this. So Jordan, this is an interesting thing to think about. If the light switch controller failed, it could possibly fall back to watching the status updates, so have Node Red normally use the light switch controller, so it's got a single source of events. But if the light switch controller fails, act on events from the devices. I can feel a sneeze coming on. I might have to hit mute in a moment, or it'll blow everybody's eardrums. I know, I think it's going away. It's all good. Yeah, so what we could do is, in fact, I haven't even got into the light switch controller yet. That's actually what I thought I was going to be showing you today. Like most of the time would be on that. We'll get to it. We'll get to it really soon. I've got the code right here. We're going to look at it. And so you press the button, the light switch controller detects it, and it publishes to MQTT. The light switch itself also publishes to MQTT because it's running Tasmota. Now that gives us two sources of the event. So in Node Red here, at the moment what we are doing right here is we are subscribed directly to the light switch, and we are watching the Tasmota publication of those events. And we're doing this without a light switch controller. If we had a light switch controller, this subscription would be to the controller, and it would be acting on those events using the controller as the intermediary. Now, what we could do is have subscriptions to both. And if there is an event that yeah, well, you'd have a bit of a race condition thing, because one of them is going to happen before the other. They're never going to happen at exactly the same time, and even if they did, Node Red is going to process them sequentially. So what you could do is have some logic inside Node Red where if it gets an event from the light switch controller and an event directly from Tasmota, so those two data sources within a certain period of time, like within, I don't know, Well, what you could do is whichever one comes in first causes the event, and that then starts a timer that makes it ignore the other source for a period of time, which could be like 5 or 10 seconds or something. It could be quite a long time. It doesn't matter. It basically masks out the other data source. So if your light switch controller failed, it would respond to events from Tasmota. And if Tasmota failed, it would respond to events from the light switch controller. And it wouldn't matter if the other event never arrived. Anyway, interesting. I'm not going to get into that right now, but Jordan, thank you for that suggestion. That is quite a clever idea. So we're going to have some fallback on this. So that way, if Wi-Fi fails, the light switch controller takes care of everything. But if the light switch controller fails, it goes over Wi-Fi and uses the Tasmota events. I like this. I like redundancy, and I like it when redundancy is automatic and it's just totally transparent. Of course, what we'd need is to be notified that there was some kind of a failure, but that's a different issue. All right, so all right, so Austin's Creation said, wonder if setting up the light switch controller with a power cycle via a MOSFET to reset a switch if Wi-Fi doesn't receive data every so often. Yeah, so basically like a watchdog timer for the switches. Yeah. Dodgy said, if your light switch controller is offline, good chance you have a blackout. Yes, true. And turning on and off light switches in a blackout, it's not very impressive. It doesn't do much. Yeah. Okay, so proof. I don't understand. All right. So Daniel said, where would you get your 12-volt supply for your switches? Batteries or wired supply? I would definitely wire it because an ESP8266 running Tasmota with Wi-Fi is not particularly low power. It's a microcontroller, but it's not the sort of thing where you can stick a battery in it and then have it run for a year or a couple of years. What you need is to be able to put the microcontroller into deep sleep, and you need to turn off the Wi-Fi radio so that it's not sucking power. Most of the power is not the microcontroller. Yes, you can run an ESP8266 for years on a battery if you put it into deep sleep mode, and if your associated circuitry doesn't have anything that, you know, parasites power, like the worst case is something like a power LED, which could be pulling 15 milliamps continuously, no matter what else is going on. So even if your microcontroller goes into a deep sleep mode and it's pulling a few microamps, if you've got an LED that's burning 15 milliamps, your battery's going to go flat. And Wi-Fi is terrible on battery life. So in this case, what I would do is hardwire power to them. That's really what this is intended for. So I've got screw terminals on here, and there's a little, this black box there is a switch mode regulator. So that's a 5-volt switch mode regulator, which then feeds into a 3.3 volt linear regulator that's on the other side of the board. So what you can do on this is put in anything between like 7 and 24 volts. It doesn't really care. You just feed it in through the screw terminals and this will run. Or you can supply power down the connection here if you plug an RJ45 socket into it. And typically I run 12 volts down all of my down my Ethernet cables to run devices. So I've got, you know, proper power over Ethernet as well, but for devices like this I run 12 volts to it. But that's not Ethernet. Just in case anybody has not seen the backstory of this, don't get confused about that. It's an RJ45 socket, uses Cat5 or whatever cables, but it's not Ethernet. Yeah, so put in front of you a switch node. Sorry, catching up again on chat. Dodgy Brother said UPS for some extra protection. Yes, I I have a UPS in my switchboard running all of that stuff. And Scott said, looks like I released an uncontrolled squirrel. No, but it was a very good squirrel. I like that squirrel. What we've ended up with is a much simplified setup as a result. So now we've gone from that to that, which is good. I like it. All right. Spit it out to a debug node. Get his attention? What? Okay. I think that might be in relation to something that I was looking at earlier, and we figured that out. So Dodgy said, wouldn't color check work if you're only working with 2 colors? Not sure. Scott said, I'm significantly older than John. I don't know, but you have more hair. Okay. You can't really see at the moment, but this is, yeah, it's graying a fair bit. There's a fair bit of grey in here. More reflective. Yeah, sorry, I will get back to all of this in a moment. I'm just catching up on chat. Then you start using lots of function nodes. All right. Hey, Matt Smith is here. Hey, Matt. Good to see you in the chat. All right. So, skipping. All right, so Austin said, do you intend to post the schematics on GitHub for the button ESP8266 board? I'd like to cross-reference from my 3D printed version PCB, and the answer is yes, and I'd be kind of surprised if it isn't already. Because I normally push stuff to GitHub even before it's done. Like I do it while I'm... Oh, maybe I haven't pushed it. That's interesting. I'm just scrolling back through my repos at the moment. And so ZeroStick, Merc. Ether. Yeah, this is ages ago. That's back in September. I've definitely done stuff since then. ESP flasher, air quality sensor. D1 Zig, ESP Max. This is getting back into ancient history now. It's August. Oh, no, maybe I did. Super button. Oh, no, super button is different. That's the, this is the assistive technology button that I've been working on with Chris. Light switch 3. All right. You got me there, Austin. So I thought that I had pushed it to GitHub, and I haven't. I'm sorry about that. One of the issues, actually, I've been restructuring my projects recently. So light switch, what you can see here is light switch 2, 3, 4. These are the simple ones. They haven't been updated since April 2018 or Feb. Wow. Light switch 3, June 2020. That's more recent than I thought. Light switch, char switch. What is going on with this one? I don't even remember which one is which. Char switch 3. I don't remember. Yeah, okay, so what you can see here is I used to store things in lots of little chunks, and it kind of got confusing. So we've got char switch 4. So this project has nothing but the PCB and the schematic file for the 4-button light switch. And then there is a different repo for the 2-button switch and the 3-button switch, etc. But what I've been doing probably for the last 6 months now is restructuring all my projects so that they are much more combined. Let's just go back to here, repositories. All right, I'll show you an example. Now this is chasing a squirrel, talking about structuring projects. All right, so let's look at the zero stick, updated 5 days ago. All right, so what you can see in this repo, and also the thing is I used to have a repo for the firmware for the project, one repo for every PCB for the project, and then there's the question of where do you put other things like design files for 3D printed cases, and it all becomes really disjointed and messy. So what I've started doing is combining these things into a project that has all the different parts of it. So you can see this is the zero stick, so the zero deflection joystick with load cells. And there's a long README that explains all of this and pictures of it and resources, etc., license. But then what I do is I've got a hardware folder, and you can see here that there are actually multiple PCBs in this folder. Oops. There's a broken link there. And this README shouldn't actually be in there. It needs to go somewhere else. So I've got the PCBs in here, and then there's a directory with images in it, just, photos of whatever it is. Resources, I stick data sheets in there so I can find them later. Firmware, and then inside the firmware directory, I've got different folders for the different versions of the firmware. So the most recent one has the NAU 7802 load cell interface on it. And back out of here, license files. And sometimes there are other folders in here as well. So what I'm trying to do is restructure projects so that they are more like this. It's one place that has all of these different resources, including both the hardware and the software, all there. Anyway, that's what I need to do for the light switches. And then hopefully it will make a bit more sense when people come across it. They won't just see one thing in isolation, like board files with no explanation. Mako said, is the badge for the big event ready? Kinda. I've got, this one right here. So this is one of the badges. Is it a current one? Oh yeah, this is a version 1.1 board. It's got, you can see it's got 2 OLEDs on it, and they're pressable, so you can click them to do things. It's got touch sliders. Right now this is not doing anything because it's just running like the base framework code. It doesn't have an app running on it. And touch buttons there, sliders, and you can do multi-touch, and it's got places where you can have sockets to plug in simple add-ons. And I just realized that I am chasing a squirrel. But the short answer is that we've now shipped about 200 of them to participants or attendees of the conference, virtual attendees. Matt said, I'm super frustrated. The topic of DIY controllers and fallback is really important to me, but I have no idea what the stream is about yet, as I cannot get the gist of it. Can anyone write me here a brief description of what John is covering today? Zero just said chasing squirrels. Yeah, okay. All right. Oh, Matt said, I'm a light switch designer myself. I made an advanced OLED physical button rotary encoder MQTT light switch controller. Ooh, very cool. I think I might have seen that, Matt. Yeah, sorry if this is a little bit of a disjointed stream today. I'm kind of trying to tie a few different things together, but a lot of it is about the specific elements. Okay, so it's hard to give a it's hard to give a summary. And all right. Oh, interesting. So, oh yes, this is a good tip. So, Gary, I'm not sure how to pronounce your name. Is it Keo? Koff? Not sure. So Gary says, hi from Ireland. Top tip for Node Red is to expand a message object in the debug window, identify the property you need, and then the copy path button to copy the full dot notated path to the property. Yeah, that is a really good tip. I use that all the time. So, well, there's no message in there right now. Let me just get it to send a message. Oh no, we don't have a debug thing in there. Okay, I'll just show you what Gary is talking about there. So I've just sent a message, it's come up in the debug window, and then if, oh, I'm not on the desktop. There we go. Okay, so I've sent a message, it's come up in the debug window, we spin it down. So say we wanted, for example, the path to this part right there of the message. What you do is you spin it down, come down to it, across to the right, there are these three little icons. The first icon is copy path. So you click that, and now if I wanted to use that path somewhere, like, well, in toggle test switch, what we're doing is, see here, we've got that bit of the path there. Now I'm just going to come down below that and hit paste so you can see what ended up in the clipboard. In fact, it's the same. So payload.button3.action, this is what ended up in the clipboard when I clicked copy path just there. And it's the path to this. And then you can see over here, if message.payload.button3.action equals single. So yeah, that's a really good tip. When I first came across this, it just saved me so much time. So if you want to be able to reference something within a Node-RED object, that is what you do. It's the quick way to find it. Alright. Oh, Matt said, I see you using these proper panel buttons with LEDs. Have you seen the little tactile switch buttons with LED from RJS Electronics PB614? Let me have a quick look at RJ614 illuminated switches. This may be a type that I've used in the past. Looking at that image, load, load, load. Yes, I do. I've got, I have many different types of switches. This is actually what I used in my very first light switches, the really old obsolete ones. So if I go to, in fact I've got some, I won't bother pulling them out. It's too much squirrel chasing, but light, if I come down here and find my really old light switch PCB, no pictures? No pictures. So this PCB, so this was from 2011, that actually used this style of switch, but it used a version that had a little, like a cylindrical stem and an LED in it. So I could, yeah, show state. It was just single color LED, obviously, with that sort of thing. It's not RGB. And where are we? Back to here. Okay. Yeah, so Dodgy said, been looking for cheaper options than the one John uses. Also prefer something that doesn't sit on top of the mounting plate. Yeah, so the way I did that, in fact I will bring that out. I've got one somewhere, I think. I should have some of my very old light switches here. So these are the ones that I used the Lego blocks as spaces to make them semi-flush mount. Oh, here's one. I'll chuck this under the overhead camera. Hopefully I will get back onto the main topic. So this one uses that style of button. It's a bit hard to see. Well, if you look on the back of it, you can see that each of the switches has got 6 pins. They are 4 for the button, so it's normally open button, and then the pair of pins that are in the center are for the LED. So the switch body, you can't really see, it's right in there. The switch body is exactly like those ones that Matt was just talking about, and then it's got a cylindrical shaft. There's an LED. If I get it at just the right angle, you can almost see it. The switch body is under there, it's black, and then there is a silver cap, and then it's mounted so that the end of the shaft is almost exactly flush with the faceplate, and you can just press it So it's so this is what my light switches did look like, back from 2011, and it's not plugged in right now, but these are actually illuminated. So these ones are blue, and I had, you can get them in all different colors. This particular one is blue, and that PCB on the back of it is that one that I just showed you the repo for, the GitHub repo, and then there's a connection that goes into a Ether 10, so that when you press this, the Ether 10 would publish to MQTT. Anyway, that is multiple generations old of my light switches. Yeah, these switches are expensive. The stainless steel buttons, yeah. But it's unfortunate, but they are expensive. Oh, Mako said, no Andy and Astra here today. No. Andy is at home working on the conference badge stuff at the moment. Ooh, Mike said he's got his conference badge. Okay, so James just brought up something that is going to get back to the topic that I wanted to cover. So James said, out of curiosity, did you end up using any code that Chris and I wrote for the new light switch controller? And my confession is, I haven't actually looked at it. I'm really sorry. I'm going to pull up light switch controller stuff in just a moment. I'm almost at the end of catching up on the chat. Okay. Yep. Also another tip from Scott. So this is following on from the thing about this debug message here. So the other tip was to find the path to any of these things within the message. Is you come down here and you click copy path. The tip that Scott just gave is if you look into this debug node, you see this drop down up the top. I think by default, if you just add a debug node, it will say, it'll be selecting to message. So it'll only output a limited amount of information. So in this case, I've changed it to complete message object, which is what Scott was suggesting. And that's how we get all of this information coming up here in the debug window. Okay, so Jochen, I think, said you can simplify that piece of code into message.payload equals get value equals true. No need for the if else and variable. Okay, that sounds plausible. I think that's right. Okay. Oh, and Jim said, hoping you'll post the Node-RED nodes and codes along with your repo push. Yeah, so where all of this is going is I need to do some proper videos and tutorials about this whole thing, about light switches, because light switches is a topic that people keep coming back to. It's it seems like one of those things that is really prosaic and boring, and when people talk about home automation, they're not usually talking about light switches as being anything that's that useful or interesting, but it's the topic that people keep coming back to. So what I really want to do, now that I've been kicked along and I've been working on this updated light switch, and I've been working on the updated controller, I want to do some updated videos. So I'll do, once I do the new controller and I've got that ready to go, I'm going to do a video just about the controller. I'll do a video about the switches, and I'll have a lot more info there. But yes, you're right. What I should do is copy the nodes. I'll copy this configuration that I've got in Node-RED and stick that into the repo as well, so that it's all there for people to reference. All right. Yeah, Matt said light switches is not prosaic. It's so interesting to me. Yeah, it It's one of those subjects that, I don't know, it seems like it shouldn't be interesting or useful, but it is. I think because it is primarily the way that people interact with their house. Other things are more specific. Light switches, you just do it all day long. Like, you're using switches on the wall all the time. So it's an important thing. All right. Now, what is the time? 11:30. What? Okay. I do want to get into the light switch controller code, and I've got that right here ready to go. But first, I just wanted to point out a couple of things. And this is going to be relevant to the light switch controller code as well. So what I've got up here with this MQTT subscription is that I'm subscribing to this specific device running Tasmota, and this is where the button events are being published. Now, and then what we're doing is some logic. So we're converting it to JSON, and then we're saying toggle test switch, and we're looking for if message dot, we're looking specifically for button 3 action here. And what we could be doing is, checking for different things, not just button 3. But at the moment, what we're doing is specifically looking for a button 3, and then doing all of this stuff in relation to button 3. But what I discovered is that there is a set of nodes specifically for dealing with Tasmota, because of course there is. Now, if we come into Manage Palette on here and installed, you'll see that there is this thing right here, Node Red Contrib Tasmota, and it provides 4 nodes, and this is really quite convenient. So I've scrolled right to the bottom here on the palette. You can see under Tasmota I've got switch, sensor, light, and button, and I'm just going to drag a button on here, and by default a button is just a single button. So what you do is come into it and you stick the device ID in here. Now, how did I do this? In this 4-way button, yeah, it was that. Okay, so you see in here I'm subscribing to that specific I've subscribed to that specific topic. It's stat Tasmota result. What you do with this, it's quite clever. You put in the device ID, in this case it's Tasmota, etc. And I won't bother with any of the rest of it. Oh, and server, you got to pick the right MQTT broker. So I'm going to pick 111, it's that one, that's my non-authenticated local broker. And if you look under advanced, so we're not going to change anything, but just look under advanced, you can see that it's got full topic, command, stat, and teller. So you can customize these, but what it does is automatically derive them from the device ID, because Tasmota publishes in a predictable, consistent way. So this is all you have to do. You create this node and you point it at the correct MQTT broker and you give it the device ID. And that's it. What you've then got is an output. So I'm just going to hit done on here. And what this will do is it uses your MQTT configuration. That's why you pick the server, and it understands the format of the message that comes back from Tasmota. So now what we could do is take this output, and button 1 is going to have stuff coming in here. So it takes the place of this specific subscription, and it allows us to take events. So the clever thing, one of the clever things here, so you can see this one I just added, all I did was add the device ID. Normally it has only one channel or all merged. So what we could do is, well, I'm going to leave that. This one down here is the same thing, except that I've selected 4 channels. So what we can do is, I'm going to get rid of that one. So what we could do is take, let's get rid of these, get rid of that, and we'll just take debug out of there, well, I'm just messing around, I'm not even sure what I'm doing here. Okay, so what I'm going to do is, oh, I know, what I'll do is I'll bring this down here, and I'll take button 4 out here, I'll turn that on, and deploy, I'll clear that. Alright, so what we're looking at here is debug information coming back from outputs 3 and 4 on this. Now this is actually connected to the same topic. So what we've got is, it's going to be coming in through here, but we can ignore all of this. Like, just act as if none of this is even here, this top part of it, and the only thing on this flow is this. What we should now see coming in from these debug nodes is events from these button presses. So if I reach over and press button 4, you can see there's an error there. Let's ignore that for now. But you can see that what's come out of this debug node is button 4 payload single. So it means that you don't have to do the JSON decoding because that's already taken care of inside here. What we're getting out is just the information we care about. And it's coming out of a different output depending on which button you pressed. So I'm going to turn off, to show you what I mean, I'm going to turn off the debug node for button 4. The debug node for button 3 is still on. So I'm going to press button 4. Oh, hang on, what's going on here? Did I mess this up? I don't know if it was deployed or not. Okay, oh, okay, yeah, we've got an error. All right, so just ignore that error for now. So I'm pressing button 4, and you see that there is nothing being reported because this debug node is turned off, and the output is coming from this output. But if I press button 3, you'll see that we do get an output. There it is, because this debug node is turned on, and we're getting the output coming out of output 3. So essentially what this does is it combines a number of different things that you might have to code up in separate nodes. By putting in this Tasmota button node, it takes care of the JSON decoding. It allows you to split the outputs, so you've got a different output depending on which button was pressed, and you get the single press, etc., multi-press. So this is really handy. It's actually really quite cool. One of the limitations is if you want separate outputs, it can only do up to 8 channels. You can't have like 32 channels or whatever that we might need for the light switch controller. So you can do a very similar thing. So what I've got here is a switch, and I've got message payload. So if it has a key of button 1, so this combined, so if we had, let's see that, and let's stick that down there. All right, and then took that into there. Let's just move these out of the way. And then took that over there. All right, and I'll get rid of that. And there's a there's a reason I'm doing this at the moment. So I'll take that and put that there. What I'm doing here is really just explaining to you what the Tasmota button does. So this is kind of equivalent. What we've got here is a subscription to the place where Tasmota publishes the result. We then convert it to a Node-RED object. We then put it into a switch, and we look for whether it has a key which is button 1, 2, 3, or 4, and depending on which key exists is going to output to a different thing, and then the result comes out here. So we're just outputting to a debug thing. So all of this functionality that you see here is what's wrapped up inside this node here. So these Tasmota specific nodes are quite cool. It takes care of a bunch of different things, and it makes it really simple to take events from Tasmota and then act on them. So we could take this output and then you know, send it to somewhere, whatever. Anyway, I only came across that yesterday. I don't know why, but it had never crossed my mind to search for Node-RED nodes specific to Tasmota. And all I did was went to Google and searched for Tasmota Node-RED, and there we are. I should have thought to do that. So yeah, if you mess around with Tasmota and Node-RED, it is worth looking at these special nodes. Add those to your palette, play around with them, and maybe they can do something useful and simplify your flows by wrapping up a number of things that you would normally do in discrete nodes and putting it into a specific node. Now, what I was starting to get at earlier was with this one, the limitation is you can only split out into up to 8 channels. So if you've got something like a light switch controller, which has perhaps 32 channels output or 64 or whatever, then you can't use this. You could do the same thing, but you have to build it yourself and then just keep adding, you know, outputs here and has keys and all those things. Let's not do that. All right, so these are 2 different ways of achieving the same end result. So what I could do is, I'm not going to do this right now because time is getting on, and I want to get into this other thing, which is light switch controller, just before I wrap up. So what I could do is put a single button in here and put it onto that, and we've got one channel or output merged, and I could take that into there, and I can get rid of these 2, and essentially it should be, I haven't actually done this, I'm not 100% sure that the message payload has the same format, but in theory the output of that and the output of that should be pretty much the same thing. I'm going to experiment with that another time, because if I did that I would use up the rest of the time, and I want to show you some other things. Yep. Ooh, so Matt said, oh, Matt, I don't know if you can post links. So Matt Smith said, I don't want to detract, you're not detracting from my stream. This is adding to it. This is fantastic. It's really cool. FYI, I made a vid showing my generic light zone scene management system in Node-RED. First 2 mins demos the idea. That is cool. Matt, I am going to make you a moderator, if I can. Let's see, mod, add moderator. There you go. So Matt, you are now a moderator in this channel, which means you should be able to post links. So if you do want to post a link to your video for your light zone scene management system, please stick it in the chat so that other people can check it out. That's great. So, where are we? Okay, back to here. Node-RED. Can't believe this almost this whole live stream has been in Node-RED. Alright, so the light switch controller. Okay, so the other aspect to all of this, after, like last weekend on the live stream when I was playing around with Tasmota and its output, let's have a quick look at this. In fact, I'm going to get rid of that, and I'm going to link this JSON output to this message, and I'm going to deploy it. So what we've got here, yeah, okay. This flow is a bit of a mess at the moment with random nodes all over the place, but okay, so what we've got is a subscription to the light switch. We're taking JSON and decoding it and converting it to an object, and then outputting it to this debug. So I'm going to clear that, and I'm going to press button 4, just because, no particular thing. So button 4. The reason I'm doing this is I want you to see the format here. This is relevant. Anyway, payload object button 4. No, what am I doing? Let's not decode the JSON. We're going to look at the output that comes directly from Tasmota. All right, so I'll press button 4 again. Now here we've got a chunk of JSON, and it's got payload is button 4 action single. So this is what actually gets published to MQTT. Now if I, just for the fun of it, I'm going to come around in here and paste it into the IDE just so you can see what it looks like. So that is the form of the message that Tasmota is publishing. It's the ID of which button was pressed, so button 4 in this case, and then it says what action it was, and in this case the action was single. So this is the message. Anyway, the reason I'm showing you this is that because I was messing around in Node-RED with being able to process the messages that come from Tasmota, I thought, wouldn't it make sense for my light switch controller to publish its events in the exact same format? So that's what I set out to do. And so what we've got here is various configuration. A lot of this doesn't really matter very much, and it's kind of self-explanatory, so I won't go into it in great detail. There's some network setup, etc. There's some watchdog stuff and display stuff and sensor stuff. Alright, you don't need to really care about that. Now, this code is still a bit of a mess. I was just hacking around on this last night. So this is basically a cleaned up version of the code to run on my light switch controller, which runs an Ether Mega. And that is why I've got this Ether Mega right here. So right at this moment, this Ether Mega is running the code that is on the screen right here. This is my little test board. So it pulls in some libraries it needs, sets some variables. So we've got MQTT topics for publishing temperature and humidity because it has an enviro sensor in it. There is a command topic where you can send commands to the controller, and there is a buttons topic where it publishes button events. Now this is the relevant and important thing, which we will get to. I'm going to skim over a whole bunch of stuff. More variables, all of the inputs. So I can't even remember how many we've got. 1, 2, 3, 4, 5, 6, 6, 8 to 48. So we've got 48 in, I could have just read it from here. Okay, so we've got 48 inputs from light switches on this light switch controller. And we've got some more setup stuff, none of that matters, blah, blah, blah. Tilt sensor, so that if the light switch controller is mounted vertically, it rotates the display. It outputs stuff on the OLED when it starts up. I am skimming through this so fast you're not going to follow it, but honestly this stuff is just like boilerplate. It's setting up the networking and all of that sort of thing. The interesting stuff comes a bit further down. Now, what we're doing here is setting up some MQTT topics. This one right here is the most important. So this is where it's going to publish the button events. And what you can see, if you look at these lines, is I've formatted them in, well, 2 of them at least, in the same way as Tasmota. So it's stat, and then there is the ID of the device, so this unique ID, and then result. So when we were looking at Node-RED earlier, look at this. This is the topic that this is the topic that Tasmota was publishing to. Stat, Tasmota, 8D, etc. So that's its ID, and then result. And then if we look at here, we've got stat, its ID, and then result. So my goal with these changes has been to make the light switch controller behave exactly like Tasmota as far as MQTT is concerned. So it then just says on the serial console when it starts up what topics it's got, connects to the broker, does all that stuff. Oh, and one thing that is slightly interesting here. So this thing, %s, what that's doing is putting in G device ID. Now G device ID is being generated automatically back up here. Now, I know this is probably a kind of dodgy way to do it, but what it's doing is taking the octets of the MAC address and it's just sprintfing them into this char array. So what we end up with is the MAC address in hex format, condensed with no semicolons between them. And in fact, I'm going to hit the serial monitor now, and what you can see right here coming out, this information in the serial monitor, because I opened the serial console, it forced the Ethermega to reboot. It then said getting MAC address from ROM, and you can see here, somewhere up here, getting MAC address from ROM. This is the code it was executing. It's reading the registers out of the I2C ROM, and says using static MAC address. And oh no, it doesn't say that because it's used the dynamic address. It's used the one from the ROM. So then what it does is it prints the IP address, and then it says what its ID is. Well, the other way around, it sets it into the buffer. I'm talking in strange circles here because the code is still a mess. So what it's doing here, okay, so we can see ID colon space and then G device ID. If you look over here, you'll see ID colon space and then that. That is the MAC address just turned into a char array without the colons. That's all that is. But what it does mean is that we can have a unique ID for this device, and we don't have to set it in the source code and that sort of thing. You don't have to keep track of it because every device will have its own ID. And in this case, it's set from the MAC address. And that means that down in here, when we're setting up these topics, we can use that device ID to generate the topic. And here you can see it reported. So we've got command blah command and stat blah result. You can see some errors there. Ignore those. That's because there is no sensor actually plugged in right now. It's trying to read from the temperature and humidity sensor, which doesn't exist, and it's getting a result which is not a number. Now, so it says nan. Alright. Outputs its topics, it connects to the broker, and loop. That whole thing is loop. That's the entirety of it. So what it's doing is checking whether it's connected to MQTT. If it's not, it attempts a reconnection. And if it's got an OLED, and it displays, basically this is the timeout on the OLED. OLED.set display on false. So 1000 by OLED timeout. Whatever OLED timeout is set in the config file, in this case it's 20 seconds. So it blanks the display after 20 seconds of inactivity. The client loop is for processing MQTT events, checks the buttons and runs the heartbeat. So the heartbeat is what resets the hardware watchdog timer and reports the sensors and things. So when we see this popping up, it's like every 60 seconds or something in the console, that is because run heartbeat is trying to report the sensors and reset the watchdog timer. Check buttons, so it's just looping through and checking each of the 48 digital inputs. Oh yeah, this is the heartbeat, we'll ignore that for now. Process button digital. Okay, a lot of this is commented out because I've been hacking around on it. It's all sorts of dodgy bits of code. But what this is doing is processing one specific button. It's called from up here. So what we do is we pass in the value of 0 and it checks button 0, and then we pass in the value of 1 and it checks button 1. So every time we call this, we call it with the button that we want to check to see if it's being pressed. And we read it and detect transitions. I won't go into that in detail because the important thing is this line right here. This is the crux of the whole thing. So what we're doing is preparing a message that's going to be published to MQTT, and we're going to squash that message into the message buffer. And this is how the message is formatted. So we've got button, and then there's a number. So you can see %i for integer, and whatever button we're currently checking. So if this was button 23 that we had been asked to check, this would say button 23. And then the action, in this case it's hard-coded to single, and button ID here is what's being passed in to %i. So the end result of all of this is that the message buffer is going to contain a message formatted like this, and if I'll just move this a little bit sideways and then come back to here, and now look at this. That formatted message right there, and this formatted payload right here. If you look in the background in Node-RED, you can see payload. This chunk of JSON, so button for action single, and over here we've got button %i action single. So the result of all of this, and then this message is published to MQTT. So the result of all of this is, with these changes, my light switch controller can now publish in the button events in the exact same format as Tasmota, which means I could even use those specific Tasmota nodes if I wanted to. But what I'm really just going for here is consistency. There's other stuff that you don't really care about. The important thing right now really is this, because what I want is when there's a button event in a device like one of these, published by Tasmota, the message is in a certain format. When there is a button event by a light switch published by the light switch controller, I want it to be in the exact same format, because it means that then you can process it in the same way. It means you don't have to have a different set of flows in Node-RED depending on for the different type of device. So one of the things that I've been doing probably over the last year, I guess, maybe a bit longer, is in setting up the code for my own projects and my own devices. If they don't run Tasmota, then I make them behave like Tasmota. So things like, you've seen this with my air quality sensor project, for example. So the air quality sensor, which is just up under there, which has been shown in a video. So I did the code walkthrough of that, the detailed code walkthrough. I think it was Superhouse episode 41, maybe. Anyway, it was a couple of videos ago. I set up the reporting in that code to look exactly like the reporting the way that Tasmota does it when it reports sensors. So that the techniques that are used to process that data can be the same. So, what does that all mean? Well, let's have a look. Let's in this one, so we've got, this is the console from the Ethermega that is currently sitting on my bench. So what I'm going to do, you can't really see it because it's in that little window. I've got the Ethermega here with a jumper wire. One end of the jumper wire is connected to ground, and I'm just going to stick it into one of the I/O lines. I don't even know which one. I'm just going to shove it into a header and see what happens. Shove it in, take it out. Okay, so you can see it said transition on 17, so input 41. So what this means is that it's detected that button 17 has been pressed, and it's reporting that that's actually input pin 41, like D41 in Arduino terms. And then what it would have done is this stuff. So let's see if we can catch that. Where is it publishing? Okay, so back in here, let's grab that and come back into node red. Let's grab these nodes. Actually, yeah, okay. I don't even know what I'm doing. This is not very well planned. Okay, so I'm going to change my subscription here and change it to that. So this is where my quasi light switch controller is publishing. Now what do I have configured? I think I've got, I think I'm running it to the unauthenticated broker. Although, let's see. I'm going to upload the latest version just to make sure that what's on there is actually what I'm showing you. Writing, and we'll just make sure that it can connect to MQTT. And then we'll see button events coming in from the light switch controller as if, cool, okay, so it's connected and we've connected to my unauthenticated broker and it's publishing to that topic. All right, so now I'm going to pull another node down here, turn that one off. We're not even using this JSON decode node right now, but that's just because I wanted to show you the raw result. All right, so what we should see now in the debug window is publications coming from the light switch controller. Now, all right, I'm going to do that again. Hang on, but first, let's move this so that we can see both at the same time. Now we have the subscription to MQTT and we're outputting it in the debug window up here in Node Red, and we have the console on the light switch controller. So you should be able to see both of those at the same time. Now I'm going to do that same thing. I'm going to shove the jumper wire randomly into one of the input headers and we'll see what happens. So if I can get it in, stick it in, pull it out. There we go. Okay, so you can see in the console, transition on 46, input 38. So that was button 46. And if we come over here and look at what was published to MQTT, we'll spin this down and you can see this was the message. Button 46 action single was published to MQTT. So the end result of this is that we now have the light switch controller, which is running this code, reporting button events to MQTT in the exact same format as Tasmota. And yeah, as I said before, that just gives us some consistency, which is good. It means that I could now take, for example, a Tasmota button node. In fact, let's do this. I'm going to come in here. So the ID is that of my light switch controller, and my Tasmota button, I'm going to give that ID, and I'll just leave it on one channel or all merged. And let's get rid of that link, and we're going to look at what comes in here. So what we should get coming out of, oh hang on, wrong broker, there we go. Let's do that. Come on, go online. Offline, why is it saying offline? Oh, it's probably just because it hasn't seen it yet. Anyway, let's just see if we do get anything. This may not work. So I'll stick that into a connection. Oh yeah, there we go. So the output, we just got button 18 popping up here. And we could take action on that in the same way. So what we're using here is a Tasmota button node, and it is reading events that are coming from the light switch controller, which is not running Tasmota. But because of this formatting, it does the same thing. So Anyway. Oh, Frederick said you could add an option for 48 channels in the node in Node Red by just adding the option as HTML code through inspecting the HTML and all that jazz. Yeah, so it could be hacked around to do it. I think in this case what I would do is probably just use the single output. So at the moment what we've got here is this. So that node is the functional equivalent of these two nodes combined. So if we leave this in one channel or all merged, it's only got a single output, but effectively what that does is it gives us the output of the thing and it decodes the JSON and it gives it to us in this format so we can deal with it directly. So that little bit there could be replaced by that single thing there. So I don't actually need an option here for 48 outputs. If you're doing it in a different way, then yes, having this do the split is nice. Maybe it's an advantage, I'm not sure. But just as a drop-in replacement for what I've got right here, that node can drop in and do the job of those two nodes. And with this, what we're doing is specifically subscribing to this topic, but with this, we're just giving it the device ID and it figures the topics out all by itself, which is nice. So, yeah, ADC, that one. Anyway, I'm not going to do it right now because I've talked enough. It's now 2+ hours. So, before I wrap up, I'm going to have a quick look at the chat. What have I been missing? Dodgy Brother said, you need to be careful. I am in real danger of understanding what you're talking about. That's my goal. You can work this stuff out, Dodgy. You're clever. Yeah, so, awesome. So Matt has posted links to his YouTube video about his zone management thing and Node Red, and also a link to his light switch. It says, which I'm almost ready to abandon or rethink. I'm going to click on that link so that those of you who haven't gone to it yet can see it. All right, so this is the link that Matt put. Oh, yes, I remember this one. Yeah, I saw this. This was a couple of years ago, wasn't it? Oh, June 2015. Yes. This is a very fancy looking switch. So, wall controller project. And there is the video. I won't get into that right now. So, this is a very fancy looking wall controller with a, looks like a brushed steel plate. Oh, yeah. Water cut stainless steel faceplate. So it's got a knob, it's got different coloured illuminated buttons. In fact, Matt, those buttons that you've used are exactly the same as the one in that old light switch that I was waving around in front of the camera earlier, that one from 2011. And there is a display in the middle. That is a very fancy looking wall plate. I like that. Dodgy said, yes, I understood most of this live stream, real scary. And Johnny said, explains it, it is dodgy code. So dodgy. So, and just to prove that, yes, dodgy, you do understand it, it says, that sounds like it iterates through every button, every loop. Yes, that is correct. And Matt said, sorry if I missed this. Am I using click button library for debounce, single click, double click, click and hold, etc.? No, I'm not. That is actually something that I was thinking of doing in to fix all of this, because this is a mess. This is a really, really crude way of doing it. There are no interrupts or anything. It's just a loop. So we've got a loop counting from 0 to 47 to count the 48 buttons. And then for each one of them, we are calling process button digital, and what this is doing is doing a digital read on the matching input for that button ID, and then it is checking if it's low, and it's checking the previous state on the button, it's checking for a debounce, and updating activity time, re-enabling the OLED to display the event on the display, so unblanking it, storing whatever the last button pressed was, saying it's detected a transition, and then publishing it to MQTT. So this is a crude way of doing it. And as Dodgy said yes, that said yes, this is checking, basically in the loop, it is just reading all of the inputs as fast as it can. It's running around in circles. And all it's doing is checking whether the button has transitioned from unpressed to pressed. And it's not detecting things like long presses or multi-presses or any of those sorts of things. So it's crude. And you can see there's a whole lot of code commented out here. So what I would really like to do is replace the majority of this code with a call to a library that does it in a nicer way, something that can detect different types of button press events. Yeah, so all right. Let's see, I'm just sort of skipping down through the chat at the moment. Sorry, I don't have time to read every single chat message because I'm past time now. All right, so Matt asked, said, John, really interested to hear your revised view on wireless versus wired. I still preferred wired, but mainly because of power reasons, but Tasmota is so good for stuff like light switches. Yeah, so my general stance, which hasn't really changed, is to prefer wired where possible, and in particular for anything that is critical functionality. So I do use lots of wireless, like I use Wi-Fi, I use Zigbee, I use 433 megahertz RF for different things. But my goal is to use wired for anything where the functionality matters, and that is things like light switches. So if a light switch fails, it's frustrating and annoying. For something like this, if I had a situation where I needed to put a light switch in place and I couldn't cable to it, but I could get power to it, I would use something like this and Tasmota and just have it rely on Wi-Fi. But if I can avoid that, I'll avoid it. I suppose that's the summary. I don't have anything against wireless, and in many situations it is the correct solution to a problem, but it depends on the problem. Yep. Cool. Yeah, I think part of it depends also on how good your Wi-Fi infrastructure is. And what I'm finding is I'm actually relying on Wi-Fi a bit more now that I've got a fairly nice Unify system throughout my house. So I've got multiple Unify access points, and I've got Unify managed Ethernet switches, and connecting them, and a Unify PoE switch, which is powering the access points. I've got a Unify security gateway, and it's just the coverage is so good, and it's so reliable, and it deals with many devices so well that I'm kind of more inclined to use wireless now, but I still see it as a problem, and particularly long term. So if I was going to sell this house, I would not want to sell the house in a state where the light switches rely on Wi-Fi to work, because who knows what the new owners would do, like in terms of their Wi-Fi. It could be terrible. Yeah. All right. Now, yeah. Oh, Matt, thanks for the tip. So, click button library is excellent. If you haven't used it, you'll like it. Yeah, cool. I haven't actually used click button. I know that there are various button libraries around. I have used and I can't even remember what it's called, but I have used another button library. I've used the one that does the matrices. In fact, that's what's in my Leopad, so my custom keyboards use that library because it handles the keyboard matrix really nicely. But, and in fact, even the Mini Open Adaptive Controller uses that library, and it handles different key inputs. And I haven't used Click Library. I'm going to check that out. Thanks for the hint. Iceberg Mama said, is there a plan to release the part 2 of the Wi-Fi video? Yes, there is. I need to finish filming it. I have recorded some of it, and the thing is that there have been several releases of the Unify software since then, so I need to re-record it anyway. I really need to just start that one from scratch. Yes. Okay. So, there was a thing here from Dentistries. In about 2 weeks' time, I'm going to sell my UK Superhouse compatible products. Can I email you, John, about sending some samples to you? I'd love your opinion on them. Yeah, I'd love to see them. So, Dentistries? Yes. You certainly can email me about them. And my email address, should I give it here? Yeah, okay, what the hell. I get enough spam anyway, revealing it. I'm just going to say it. I'm not going to put it in the comments or anything where it can be harvested. But if you're listening to this video, the relevant email address is John, Jon, at superhouse.tv, which is something that many people could have probably guessed anyway. Yeah, so my 2 hours is well and truly up. I need to go and get some lunch and maybe have a drink. So I'm going to wrap it up, but thank you very much for coming along and hanging out with me on a Sunday. Oh, one last thing I just remembered. Next Sunday there will be no live stream, and that is because next weekend there is LCA 2021. Saturday is going to be the Open Hardware Miniconf, and it's not too late to register. If you are interested in open hardware and you want to see some interesting talks, there are some really, really cool ones. There's going to be a talk by someone from an FPGA company about some how they've gone to a fully open source toolchain for their FPGA software. And there is also going to be a talk by the developer of the what was it called? The X65 project, which is a Commodore 64, and it is just an epic project. It's basically a modern version of a Commodore 64. And in this project, they went to the extent of designing a custom case and having it injection molded, and it looks like something that you would buy from Commodore. It's amazing that someone, to me, that a hobbyist project went to the trouble of building something that looks this good. And there's going to be a talk about that at the Open Hardware Miniconf as well. And there are, what you can do if you're not interested in the whole conference is you can get a ticket just for the Open Hardware Miniconf if you want to. There is a Miniconf only ticket, and it's streaming online, so it doesn't matter where in the world you are. So if you are interested, I should stick the URL in here. Let me see if I can. Oh, here we go. If anyone is interested in doing this next weekend, I'm going to drop the URL into the chat, and you can sign up for a Miniconf only ticket and come along and see me and a bunch of other people talking about open hardware topics. And so, and keynotes. Lemore Fried from Adafruit is doing a keynote, and who are the other keynotes? Oh, Corey Doctorow is doing a keynote. That will be really cool. And the other keynote, where are we? News. Sorry, I'm in the process of clicking through. Right, and the other keynote is Omoju Miller, and Omoju's talk It sounds like it's going to be really interesting. Amochu is technical advisor to the CEO at GitHub, and so her expertise is machine learning and computational intelligence, and she's going to be doing a keynote as well. So all really cool stuff. So next weekend, so Saturday, Sunday, Monday is LinuxConf AU, and hence no live stream. Sorry. But you can come and join me. Oh, John Spencer just said 4 days to write my Open Hardware Conf talk. Sounds about right. Yeah, so John Spencer, who is in the chat here, is one of the speakers, and I may actually be teaming up with him to do part of the hardware talk, talking about these badges. So John did some of the design work on the badge, and Andrew Nielsen did the PCB layout. So I think John did the schematic and Andrew did the PCB, something like that. Yeah. How am I still talking? What am I still doing here? Are you still here? It's long after 2 hours. I'm going to go. Oh, Paul. So Paul asked, are there still spots for speakers in the Open Hardware Lightning Talks? Unfortunately, we can't do Lightning Talks this year. There was just no way to structure it because it's live streaming, and trying to do the transitions tightly on Lightning Talks was just too hard. Unless the only way we would have been able to do it is to get everybody to pre-record their Lightning Talks and then edit them into a single video and then like just run the video. And it was just too much. So unfortunately there are no Lightning Talks this year. Sorry, Paul. I would have... Dodgy said, you're still talking, we're still here, stop talking. Yeah, one day I'll give up and have my lunch on the stream. No, I will go. I will go. Thank you for coming along. If I don't see you at the Open Hardware MiniConf next weekend, I will see you in 2 weekends at the next live stream. I don't know what it will be about yet, but maybe interesting. Maybe I'll have lunch. Thank you very much. Have a great Sunday afternoon if you're in Australia or wherever you are in the world. Thanks. Bye.